Hello everyone. Today we are going to discuss about the concept of Android application development. Let me start with the basic introduction about the Android, how it was actually developed. Let me explain the history of Android. Actually, it is a open source Linux based operating system. Especially it is designed only for mobile devices such as smartphones, tablets or computers like that. Especially Android is a Linux based application. It was developed by the Open Handset Alliance. Actually, it was led by Google and other companies. They started a project based on the mobile based application. Then later on they developed other applications also. The Android OS is a Linux based one based on the Open Handset Alliance. It's a short form of OHA. Google started creating the operating system in the early of 2005. They started creating the operating system especially for mobile devices. Then later on they gradually increased their features of the operating system. Then the first beta version of the Android software development kit, actually it is also called SDK, was released by the Google in 2007. Actually it was the first commercial version released by Google. It is also called the version Android 1.0. Actually it was released in the September 2008. So afterwards the usage of the Android was gradually increased. So the Google also planned to develop the Android versions. So this is the basic introduction of about the Android OS. Then what are the features available in the Android features? See, these are the some of the features which are available in the Android OS. Actually it is a open source operating system, so that any user can able to install and modify the concept of this operating system. So actually it was developed by Java based operating system. Then the other features are reduced development cost. See, since it is an open source software, so any user can able to create ready applications with the help of this Android operating system. So it reduces the development cost of various applications which are ready to execute in the Android OS. The next one is called large user base. Since it is open source, maximum number of users are using this Android based mobile phones, so the usage is become more. The next feature is called application integration. See, and the Android devices supports various kinds of application like browser or any other applications like various types of applications like Google Chrome browser and Google Maps and various applications which are very easily accessible by the user. So that's what the application integration part is crucial. Then the powerful operating system, actually GSM technology actually plays a major role in the Android OS. Global system for mobile communication is the major what to say, it's a major kind of SIM card, which are SIM card based technology, which are opted for various service providers. So it's a very fast using technology based on the GSM technology. Each and every Android device works very fast, like 3G, 4G and even 5G also they are using with the concept of GSM technology. So each and every GSM technology based SIM card having the each and every SIM number, similarly PIN, PUC, everything comes within the concept of GSM technology. Then the next features are called optimized graphics and media support. So each and every Android device is capable of executing or playing various kinds of audio or video based files, so that the user can able to execute or play, or even they can perform with the media supporting. All those things can be performed very quickly and easy manner. So these are the basic features of the Android devices. Let us move on to the next thing. Since it is an open source project, so we can customize the OS based on our requirements. See, if you want to create a project or even an application with the help of the Android, it will be very easy, because we no need to pay for additional cost for installing all those things, additional supporting softwares, or even other tools for developing the Android based applications. And then it's a very easy task to perform or create a project for even students also. See, they have different types of connectivity like GSM, CDMA, Wi-Fi, Bluetooth. So these are the various types of connectivity mechanisms which is adopted by the Android. See, GSM and CDMA, they plays a major role in the Android, because they use the concept of GSM uses the concept of SIM card, whereas the CDMA, that is also a type of technology, code division multiple access, which is used in the various mobile devices for communicating with the user as well as the network service provider. The other things called Wi-Fi and Bluetooth, so they plays a major role for information sharing between various Android devices, or even Android device along as well as with the PC or various mobile devices. So these are the major types of connectivity which are available in any Android devices. Then Wi-Fi technology can be easy to share with other devices. With the help of Wi-Fi technology, we can able to play games, or even sharing the files from one user to another user. So they are very much available, and then powerful technology for communicating the information sharing. GPS is also plays a major role in the Android device. See, GPS is called Global Positioning System. So it has a major concept called location tracking. Suppose, for example, if you are using a mobile phone while you are on the driving, with the help of GPS, you can able to identify exactly where you are locating in your geographical area, so that the person can able to identify where is he located. Similarly, with the help of Google Maps, he or she able to find out the location all around the world. So with the help of that GPS, we can able to identify the position to the location or position where we can go to a particular position. Similarly, file manager is a concept. It's a tool to identify the various storage related activities for various files concepts. There are various media supports files like AVI, MKV, FLV, MPEG or the audio or video supported files. They are stored in the file manager also. It also supports different image formats like JPEG, PNG, GIF, BMP, MP3. MP3 is a kind of audio concept. So these are the various kinds of image as well as audio files which are supported by the Android device. And then similarly, it also supports multimedia hardware to control to perform playback or recording using camera and microphone. So these are the overall features. They are readily available in any kind of Android platform. Then we move on to the various kinds of versions. They are readily available. That means they have adopted each and every version. See, the initial version is called Android 1.1. That is a level. API level means application programming interface level, which was the base concept. Initial thing is 2, that is called base 1.1, that is 1.1. Then gradually the company that is created each and every Android version to develop various platforms from 1.1 to Android 6.0. So each and every version they have a different name like Cupcake, Donut, Eclair, Freo, Gingerbird, Honeycomb, like that. They have given each and every version. Similarly, the platform version as well as version code for each and every version they have given. See, if you look at this picture, we can able to identify the major versions of the Android. The initial version is called Android 1.0, which was actually released in the year of 2008. Then 2009, the Cupcake, that is 1.5 released. Then 2009, it's a Donut. Then 2009, they renamed it to 2.0, and then Eclair, that is another name. Then 2.2 in the year of 2010, they have given the name called Froyo. Then 2.3 is called Gingerbird in the 2010, and then 2011 3.0 is a version or called Honeycomb. Then 4.0 Ice Cream Sandwich in 2011. Like that, they have given each and every version they have given similar name like Jelly Bean, Kit Kat, Lollipop, Marshmallow, Nougat, Oreo. Then 9.0 is called Pie. 10 and 11 finally. In 2021, they have given Android 12. Then finally, in 2024, the latest version of Android is Android 14. See, this is the latest version which is going to be yet to be released. So these are the Android versions from initial state to latest release. See, now we move on to the Android Open Stack. See, each and every Android device which has the OpenStack platform, that means it functions based on the OpenStack. So it has divided into 6 categories. That is called, first one is called system apps. The system apps is nothing but the existing applications which are available in each and every Android device, irrespective of the versions what they have installed. See, each and every mobile device they have a inbuilt system apps. For example, dialer, email and calendar and camera. So these are the some of the examples of system applications. Not only these four, apart from these four applications, they have n number of additional applications are available. So without the system application, the system cannot be able to function. Apart from the system apps, they have major concept called Java API framework. Java API framework is nothing but it's a framework for running various applications like application programming interface. It manages the various kinds of activities, location, package, resources, telephony and window. So these are the some of the operations of the Java API framework. Then the third layer has two subcategories called native C++ libraries and then Android runtime. So these are the two sub concepts in the third layer. The native C++ library has several libraries to support and execute for various Android operating system functions. Then the Android runtime, it plays a major role in any Android operating system. See, it has ART, that is called Android runtime, and then core libraries. The core libraries contains various library files which are mandatory to execute any kind of Android operating system, that is any versions of the Android operating systems. The Android runtime, it executes the core, that is actually it's also called the core of the Android OS, because it executes the each and every system applications as well as user created or user defined applications with the help of core libraries. It is going to be executed in the Android runtime only. So this is the major role play in the Android OS. The next thing layer is called hardware abstraction layer. It is also called HAL. It is going to communicate with the various what's so called concepts called audio, Bluetooth, camera and sensors. So the hardware abstraction layer is going to perform with the camera. Take for instance, if you take a picture with the help of the camera in your mobile, the hardware abstraction layer is going to communicate with the camera and it instructs the camera to capture an image or even a video. After capturing this image or video, the hardware abstraction layer can communicate with the libraries, that is called core libraries, and then it finally going to save the captured image into a particular location. So this is the concept of hardware abstraction layer, that is the contribution of this camera interaction of the HAL. Likewise, it is going to interact with the sensor, similarly Bluetooth for communicating the information from one device to another device. Similarly, it is going to play an audio or play a video file. Like that, the hardware abstraction layer works. Then finally, the Linux kernel. So the kernel contains various concepts like drivers. Along with the drivers, inside the driver they have audio. Each and every audio or video, or even if you want to display a picture or even your video, drivers are the major things which helps us to pass the information from Android runtime to kernel. So with the help of the drivers only, we can able to communicate with the devices like display, camera. So the hardware abstraction layer has to be interacted with the drivers for capturing an image. So the drivers, similarly HAL, both the concepts are very crucial for taking the image or even recording the video. Then the final thing is called power management. So the entire thing of the OpenStack needs power consumption. So the power management is transferring the power supply to all the things. So this is the main concept of executing an operating system, that is called Android OpenStack. See, let me explain in detail. For instance, Linux kernel. So it's the heart of the Android architecture that exists at the root of Android. So Linux kernel is responsible for device drivers, power management and memory management, device management and resource access. So without the kernel, we cannot be able to process any kind of memory or device or even a resource. So it is the heart of the operating system. Then the native libraries contains various libraries like OpenGL, SQLite, Media, C runtime library, etc. So with the help of the library only, we can able to perform some tasks, like take for instance SQLite. See, the SQLite is responsible for storing and retrieving the data into the database. So with the help of this SQLite native library, we can process the user data. The Android runtime has core libraries and DVM. It is also called Dalvik virtual machine. Actually, the virtual machine is nothing but actually a machine which is not actually exist. That is called virtual machine, which is responsible for to run the various applications. See, actually, if you create a application in an Android based thing, the application is going to execute in the Android virtual machine, that is called a Dalvik virtual machine. Before executing the thing, it has to compile the application. After compiling the application, it is going to generate a concept called just in type compilation. Just like in Java, they have bytecode. Okay, so the bytecode, if you create a program in Java, first thing, it is going to be converted into a class file. Then the class file is going to be executed in Java virtual machine. Then it converts the class code into bytecode. That is called just-in-time compilation. Then finally it executes the code into machine understandable form. Similarly, here also it executes like that only. So the Android runtime consumes less memory as well as fast performance. So these are the additional functionality of the Android runtime. See, now we move on to the Android core building blocks. See, if you create an application in Android, so there are 5 basic building blocks. They are called activity, intent, service, then broadcast, receiver, content, provider. So these are the 4 building blocks of the Android application. So what do you mean by activity? See, activity is nothing but a class that represents a single screen. If you open your mobile, in that mobile, if you want to chat with your friend using the WhatsApp, so it is a single screen. Okay, so this is called activity. So it is like a frame in abstract window toolkit in Java. So the activity is nothing but the current single screen. The second thing is view. View is nothing but the user interface. Such as a view, you might have some buttons, labels or text box or any field which is you are going to interact with that. So that is called a view. That is also called user view. The next one is called intent. What do you mean by intent is to invoke components. It is mainly used to, for example, if you want to play an MP3 file, or even if you want to play a video file or audio, or you want to launch an activity, then displaying a web page or display a list of contacts. So these are some of the examples of intent. Or even if you want to call to your friend, you have to dial a phone call. So all those things comes under intent. So these are the major core building blocks of the Android. What about the remaining 2 things are called service and content provider. So service is nothing but a background process that can run for a long time. Take for instance, if you are playing an audio track, then you are minimizing the audio track. After minimizing the audio track, you just switch over to your WhatsApp and chatting with your friend. So in that time, the audio track is in the background, so it keeps on executing the song. Once if you stop the song, then only it will stop, otherwise it is in the background. So this is called a kind of service. So there are 2 kinds of services available. First one is called local and remote. The local service is accessed from within the application. That means if you open an application, so in that application itself a service is executing, means that is called the local service. Similarly, if a service is running in remote area, that means remotely from other applications also, so that is called remote service. So this is another core building block of the Android. Then the last one is called content provider. So with the help of this content provider, we are used to share the data between applications. Suppose if you want to share a WhatsApp or Facebook contact to some other application, we can share the data between one application to another application. So this is called content provider. Okay. Then finally we move on to the fragment. See, the fragments are like a part of activity. An activity can display one or more fragments on the screen at the same time. Take for instance, if you are opening a web page, so in that web page you have 2 buttons. If you click on the first button, it performs some task. Suppose if you click on the second button, it is going to be transferred to some other web page. So this is the concept of fragment. A web page contains 2 activities. If you click on the first one, it has a separate activity. If you click on the second button, it acts accordingly. Okay, so this is the concept of fragment. Okay, see, these are some of the features of Android which we have already discussed. NFC means near field communication. So this is the major concept, like Wi-Fi. With the help of Wi-Fi, we can able to transfer files from one Android device to another device. Likewise, NFC is also performing the same task. Similarly, multiple language support, multitasking. Multitasking is nothing but performing n number of tasks at the same time. That is, one task is in the foreground, that is the active task. The remaining tasks are in the background. Just now, as I said earlier, if you are playing an audio track in the background and then opening a WhatsApp chatting is in the foreground. So this is called multitasking. Then connectivity, storage, battery optimization, and custom build, security. So these are the additional features of Android. Then finally, we have the applications. Where exactly the Android applications are used? See, these are the some of the applications which we are using the Android OS in the form of mobile, like education system, healthcare, social media, gaming console, banking, smart home, and then smart watches, e-commerce. Where in the healthcare, with the help of Android device, we can able to monitor or we can track the patient's case history. Even if you are sitting in the home itself, we can able to communicate with the doctors. Okay, so this is the major recent advancement in the Android application. Similarly, social media, each and every person, we are using the social media for sharing the information. Then banking, suppose if you want to transfer or receive or money from the bank, in early days, that means over 40-20 years back, we used to go to bank and you have to fill the forms and chalons, all those things, and give it to the cashier. Then we have to wait for some time, then they will give the money back to us, then we will come. So it takes almost 2 to 3 hours minimum time to withdraw or deposit money in the banking sector. But nowadays, even we don't even go to bank at all. With the help of mobile application itself, we can able to send and receive money, as well as not only banking application, we can use various kind of UPIs for transaction. Even for shops and all, we go just purchase something and we can just simply, the help of UPI, we can transfer money from one account to another account. So the Android applications are plays a major role in banking also. Okay, so some of the other applications are also available for all the users. Okay, so these are the applications of Android devices. Okay, see, that's all for now. For introduction, I have given the basic idea about the Android applications. Thank you for watching. Thank you. Have a nice day.